This video is called Increase Accuracy, Increase Profits, Estimating Commercial Electrical Projects. Now I have on the screen a drawing, and what I want to point out is to increase accuracy, which increases profits, you have to make sure that everything is included in your estimate. And the plans are one-dimensional. They don't show you everything that you need. Now here's a great example. This is a very small project. It's a small building, a medical building. And I just want to explain that this new panel SCS right here, now you don't know this, but I'm going to tell you, it's a 600 amp three-phase panel, okay? And over here, this panel LA is actually also a 600 amp. Now, the SCS panel is outdoors, and of course, the panel LA is indoors. Here's my point. When you're estimating things like this, you have to make sure that you include everything. Here's what I'm talking about. In this instance, this is a weatherproof panel. It's outdoors, and you're required to penetrate the top of that panel with Myers hubs. So what you would do is make sure that you would, on your material takeoff, that you would include Myers hubs. Now, in a minute, I'm going to show you an example, just a simple example of the materials that are on a takeoff sheet, okay, for this. And I'm just going to show you the stuff that's kind of hidden. So to that point, you don't want to forget those Myers hubs because they're kind of expensive. Now, the other thing is I happen to know that 2 3-inch EMT with 4 350 MCM and 1 number 6 have to run from panel SES over to panel LA. Now, in order to do so, here's something else that you want to make sure you pick up on. There's a couple different things. There's a lot here. For one thing, you have to penetrate this wall right here. You see the wall? You would probably come out of the top. This is the way I would estimate it. You come out of the top here, set a Myers hub, run your conduit up through the wall, over and down into this panel, LA, again, which is a 600 amp panel also. So here's what the plans don't show. You have to penetrate this wall and you have to seal it, okay? So Red Rhino Estimating Software, I should start by saying, has Myers hubs in it, all different sizes. This would require 2 3-inch. Red Rhino has core drilling in it, labor for core drilling. And there's another thing that's unseen here. You can't just stick a 90 of conduit going out through this wall. You have to transition it. This is a great example of using some material that's transitional. And here's what I mean, from outside to inside. In this instance, I would use either 2 LBs, and again, these are parallel feeders, 3-inch, 2 LBs, or a big junction box on the wall up high and probably out of sight here. So in this instance, I put 2 3-inch LBs. So again, there's Myers hubs, there's penetrating this wall, there's sealing that penetration, there's LBs to transition through the wall, and then of course you just continue your conduit over into this panel. Now, Red Rhino Estimating Software has tons of tools. It has this thing called a conduit wizard where you can input the conduit for that just really fast. Of course, you just measure it and put in the length of the conduit in the conduit wizard. This isn't about that. Something else I want to talk about just on this drawing real quick is over here we see an outdoor disconnect, and this conduit has to go to panel LA. Again, this is outdoors. So another instance is somewhere this conduit, the conduit feeding this disconnect switch down here on the left, CU-E2, it has to penetrate, again, the wall, okay? So core drilling, and then transition also. There'd be a junction box in here, more than likely, or an LB, something to transition from outside to inside, okay? Now something else that's just, you probably know this, but let me just say it out loud. So well, I guess I didn't define the plans that well. Let me go on and define it better. This panel LA feeds this transformer TB. So here's the deal. There's 2 transformers here, and you don't see the sizes. The big one, TB, is actually 150 kVA, and the TA is 75 kVA. So obviously they're stacked. The rest of the story is you would need transformer brackets for transformer TA. You would need some kind of equipment. That thing could weigh over 300 pounds. You'd need some kind of a lift or equipment to lift it up. So this is exactly what I'm talking about, to look through the blueprints or see through the plans and make sure that you include everything that's needed, okay, to protect your profits, okay? And it makes you more accurate. Now, I just have one more thing to say about that in terms of technique. I always measure my conduit. Now, this isn't about that, but I'm just going to say it. I always measure my conduit right angles to the building. In other words, this PTAC unit here, AC unit, is fed to panel HA right here. I would not measure the conduit from HA diagonal across here. I would measure the conduit over and up, okay? Same with this AC unit outside. I would measure the conduit, again, it's going to panel LA. I would measure the conduit over and up, okay? So I hope this helps. This is a really quick example of seeing through the blueprints so you can increase accuracy and increase your profits when you're estimating commercial projects. Hope that helps. This is an example here on the takeoff sheet of items to include. Now, again, my purpose in this video is just to show you stuff that's hidden, stuff that isn't obvious to you, maybe not, but you want to make sure it's included. Notice how I listed 2 3-inch Myers hubs, 2 3-inch LBs. Now again, Red Rhino Estimating Software has all these products in it with pricing and labor. 2 4-inch core drills. Of course, you have to oversize the core drill for a 3-inch conduit, right, to the outer diameter. So close is a 4-inch core drill, 4-inch core drill patch, and then transformer wall bracket, okay, for that 75 kVA transformer. Okay, so that's it for this video. Thanks for watching.